This video is going to be a quick review before our quiz, as well as an introduction to polynomial division. So if you could turn to page 60 and spend about 2 to 3 minutes just graphing these two functions using your knowledge of roots and end behavior. Okay, so you should have tried these on your own, and the first thing I noticed that number 1 has is a negative leading coefficient, and I know that it has a degree of 3 because it's like 1, 1, 1 makes 3. So I know that on the right side it's going to be going down, and on the left side it's going to be going up. And I don't need to write this out formally because I'm not asked for the end behavior. So now I'm going to put my zeros in. I have a 0 at 0 because that's just x, at 3, and at negative 4. 1, 2, 3, 4. Right. Now I also know that these are all single zeros because there's like no exponents up here. So my graph is just going to come normally, and as long as your graph kind of resembles mine, you are good to go. Now number 2 is a little trickier because it is not given to us in factored form. The first thing I do notice that it is degree 4 and it has a positive leading coefficient, so it's going up, up. And now let's factor. So I notice that everything here is divisible by x squared. So I'm going to take out an x squared, and I'm left with x squared plus 4x plus 4. Now I'm going to factor x squared plus 4x plus 4 because I can figure out what adds and multiplies. So that's going to be x squared times x plus 2 times x plus 2, which is the same thing as x squared times x plus 2 squared. So now I have two zeros. I have a 0 at 0, and I have a 0 at negative 2, and I notice that both of those zeros are double roots, double, double. So when I graph them, 0, negative 2, I'm going to have tangent points here. So I'm going to have to be careful. I don't want to accidentally cross the x-axis again, and I want to make sure it goes up, up. So I'm going to bring my graph down, and it's going to kind of look like a W. I didn't use that arrow, that's okay. And so there is number 2. Okay, so what I'd like you to do is just turn to page 61, and we are going to look at a little bit of division. We are not going to do partial quotients. They're dumb. I don't like them. Don't worry about it. All right, so if you look on the far right, we have this old school long division problem. And if we were doing this problem, we would think 23 goes into 48 how many times? Like if I'm dividing 48 by 23, that would go in twice. And I would do 2 times 23 would be 46. So divide, multiply back. Now I'm going to subtract. 48 minus 46 is 2. And now I'm going to bring down the 7. Okay? So now I would go 23. I'm going to divide 27 by 23. That goes in once. I'm going to multiply back. I'm going to subtract and bring down the 6. And sure enough, 23 goes into 46 2 times. So my answer is 212. And that's long division the old algorithm way. So what I want to do is you'll notice over here I have a box set up for the area model. And you'll notice that I have written the divisor on the right, and I have my dividend, what I'm dividing into, I've broken up into place values, so thousands, hundreds, tens, ones. And what's going to happen is whatever I write up here, this is going to be my quotient. Okay, this is what I'm dividing into. This is my dividend, this is my divisor, this is my quotient, this is my scratch work. So here's how this works. I need the diagonals to add up to 4,876. So obviously there's only one box on this diagonal, so I have to put a 4,000 here. Okay, so now I think 200 times what gives me 4,000? 200. Okay, so because I put the 200 up there because 20 times 200 would give me 4,000. So now I'm going to do 200 times 3, which is 600. All right, now this diagonal has to add up to 800. This is 600, so I know this box has to be a 200. So that way it adds up correctly. So now 20 times what gives me 200? 20 times 10. Now 10 times 3 is 30. Okay, so on this diagonal, it needs to add up to 70. So I have a 30. This has to be a 40. All right, so now 20 times what gives me 40? 2. 2 times 3 is 6, and that's what I have here, so there is no remainder. And if I add up my quotient line, 200 plus 10 plus 2, I get the same 212 that I got from long division. All right, so what we're going to do is we are going to do both long division and the area model for the division of these two polynomials. Now I'm actually going to do the area model first because I think you're going to be more comfortable with it. So I want you to notice how I've set it up, just like before. I have the divisor going down the side. I have my dividend, what I'm dividing into is written along these edges, and I need these diagonals to add up to these 4 values. So I'm going to start by taking my 4x to the third and putting it in this box. Now I want to point out, because you're going to have to draw these boxes yourself in the homework, you just need to make sure that whatever your divisor is, that it's in standard form. So like if this was x squared plus 3, I would definitely need a row for 0x. But because this is just like a linear divisor, 2x plus 3, I don't need any other rows. It doesn't need to be a perfect square. It can be a rectangle. So now 2x times what gives you 4x cubed? 2x times 2x squared gives me 4x cubed. So now I'm going to multiply. 3 times 2x cubed gives me 6x squared. Sorry, I said cubed, that's a squared. And I need this row to add up to 8x squared. I have a 6x squared. This needs to be 2x squared. So now I'm going to think, 2x times what gives me 2x squared? Obviously, this is an x. Multiply back. 3 times x. I get a 3x. I need this to add to 7x. So 7x, if this is a 3x, this must be a 4x. Now 2x times what gives me 4x? 2. Multiply back. I get 6, and I have no, because these guys match, I have no remainder. And so my quotient, my answer is going to be 2x squared plus x plus 2. All right, so that's the area model or box division. So if I want to do this polynomial division using long division, this is a little trickier. So over here in my long division, I started with 23 goes into 48. Well, here I'm going to think to myself, 2x goes into 4x cubed. And I'm actually going to have like a little thought here. You know how like a thought bubble. 4x cubed divided by 2x is 2x squared. So I have this thought, just dividing my leading terms, and I'm going to write that up on my quotient line. 2x squared. So I have a division thought. Step 1, write that down. Have a division thought. Now I'm going to multiply back. So 2x squared times 2x is 4x cubed. 2x squared times 3 is 6x. Now I'm going to subtract and bring down. And you notice I'm grabbing another pen here because I want to make sure I subtract everything. So now 4x cubed minus 4x cubed, boom, 0. 8x cubed minus 6x, I'm sorry, 8x squared minus 6x squared is 2x squared. And now I'm going to bring down the 7x. For polynomials, I like to bring down everything so I don't forget. Have a division thought. Multiply back, subtract, and bring down. So now we're going to repeat. I'll do this one in green. I'm going to have a division thought. I'm going to grab my 2x squared, and I'm going to divide it by 2x. That's my division thought, and that gives me x. I'm going to write that on my quotient line. Have a division thought. Now I'm going to multiply back. X times 2x is 2x squared. X times 3 is 3x. Have a division thought. multiply back, subtract, and bring down. So now when I subtract this, 2x squared minus 2x squared is gone. 7x minus 3x is 4x, and I'm going to bring down my 6. Switch back to blue. What am I going to start with? I'm going to start with a division thought. I'm going to grab my 4x. I'm going to divide it by 2x. That gives me 2. So I'm going to write that up on my quotient line. I had my division thought. Now I'm going to multiply back. 2 times 2x plus 3 gives me 4x plus 6. Now when I subtract, I have no remainder. And I want you to notice that I get the same answer. So that's an introduction to polynomial division.